Okay, so for our final topic of the week, here's the big ideas you should pull out by the end. What is a pyramid of energy? What is a pyramid of numbers? How can a pyramid of numbers be inverted in some ecosystems? What's a pyramid of biomass? How can a pyramid of biomass be inverted in some ecosystems? And in all three types of the pyramids we're going to do today, what happens to the amount of living stuff as you go up the pyramids? So, as you probably guessed, okay, today is about ecological pyramids. Now, this kind of continues our theme of looking at ways to represent energy flow in an ecosystem. So the nice thing about ecological pyramids is that they show how fewer organisms can be supported at each additional trophic level, right? Why is that? Because of energy loss, right? There's the second law of thermodynamics. Also, the fact that, remember back to our lynx and our rabbit, one lynx does not eat one rabbit and be done, right? It needs to eat many rabbits. So in the step below the lynx on the food chain, in the rabbit level, there needs to be a lot of them to support even just one lynx. So there's three main types of ecological pyramid: energies, numbers, and biomass. So for a pyramid of energy, it's really just kind of a food chain turned into a pyramid, right? But it gives a better picture because now you can kind of see how, oh yeah, there's fewer of these things. A food chain can kind of make it just look like one flower, one mouse, one fox, whatever, right? So the energy at the bottom is always fixed. It's based on how much photosynthesis occurs. And then after that, we know from the 10% rule that just divide by 10 every time, and that's how much energy will be at each level, right? So there are no exceptions. Every energy pyramid always looks like this, okay? So each level has 10% of the energy that was available to the energy below it. So you can see here, purple coneflowers have 1%, divide by 10, 0.1%, divide by 10, 0.01%, divide by 10 again, 0.001%, right? And you get the idea here that there's way more purple coneflowers than grasshoppers, and there's way more grasshoppers than yellow warblers, and there's even more yellow warblers than there are peregrine falcons. So what it's showing here is the amount of energy available at each level, right? So there's a lot of energy down here. In all of the purple coneflowers, there's tons of energy, but only 10% of that can make it to the next level. So you have a smaller amount here, 10% to be exact, right? And then you have 10% here and 10% here. And that's what these are showing, 1%, 0.1%. You'll notice this is dividing by 10 every time, right? So practice, it asks us to turn one of the food chains on page 9 of these notes into a pyramid of energy. And then if the producers have 10,000 kilojoules of energy available to them, write in the amount of energy available at each other trophic level. So let's just go to page 9 quick. Well, they did this one for us, so let's do this one. Okay, so at the base, the producer was algae. And then one level up from that, they had mosquito larvae. That's the primary consumer. Then the next level up was dragonfly larvae. And above that, pike, the fish. Okay, the tertiary consumer. So it's saying if the producers have 10,000 kilojoules of energy available to them, so that's how much energy there is down here. Okay, remember, 90% of this energy is getting lost as heat or used up by the organism, right? So 90% of the energy leaves every time the transfer happens, and only 10% actually gets transferred. So 10% of that will get transferred, and then 10% of that will get transferred, right? So you have 10% of 10% of 10% of 10%. So that just means divide by 10, or maybe simpler, drop a zero. So we have 4 zeros, we're going to have 3 zeros at this level, okay? And then drop another zero, so this will have 100 kilojoules, and the pike would have 10 kilojoules of energy available to it. And that would mean at that level, there are 10 kilojoules of energy available. And all this means is that's where the energy is kind of hanging out, right? So at the pike level, there are 10 kilojoules of energy hanging out. At the algae level, there's a lot more energy, which makes sense because 90% is lost each time you move up the pyramid. Okay. So really, the pyramid of energy is the best one, the most accurate picture of how energy moves through an ecosystem, okay? But the problem is, how do you measure energy, right? You can't really do that. What you can do is make measurements like, well, go count the organisms, okay? So the pyramid of numbers is just that. Go count the number of organisms at each level. Of course, the number of organisms decreases as we move up the pyramid because of what we saw in the pyramid of energy, right? There is less energy available, so fewer organisms can be supported. So notice, it looks the exact same. It's just that now, instead of saying how much energy is available, we're literally saying how many purple coneflowers. So here they have a million grasses while they're doing multiple producers, okay? So that much, a million coneflowers would need to be around just to support 100,000 grasshoppers. And 100,000 grasshoppers would need to be around to support just 500 yellow warblers, right? And 500 yellow warblers would need to be around to support just 2 peregrine falcons. So this one, you really do just go into the ecosystem, imagine pausing time and counting up every single organism. And it will always look like this. Now, there is never an exception to the pyramid of energy, the last one we looked at, because that was the laws of physics, right? 10% of energy is actually passed on. No getting around that. This one can have an exception. It can sometimes look different. Now, usually it looks like this, but there are cases where it's not. And so a good example is something where the producer is really, really big and the primary consumers are really, really small. So the energy doesn't change because there's still a lot of energy. It's just that it's stuck in one big producer. So I want you to think of like in a forest with really big trees and a whole bunch of tiny little caterpillars and insects that are eating the trees, right? So in that case, just one producer can actually support a whole bunch of primary consumers because the primary consumers are very small, have very low energy needs, and that one big, huge tree has a lot of energy. Okay. If your producer is really big, right, you could have one big producer with the same amount of energy as a whole bunch of little producers. The end result is the same, that the amount of energy at every level decreases. It's just that for a pyramid of numbers, you might actually count, for this example, more insects than you do trees because the trees are big. One can support a lot. But then it usually looks the same after that. But then it kind of usually looks the same after that. So maybe you have one tree supporting 10,000 caterpillars, which supports 100 birds, which supports one hawk or something like that. Okay, the third and final type of ecological pyramid that we're going to look at is called a pyramid of biomass. Like the name suggests, it shows the mass of the living tissue at each trophic level. So instead of just numbers, now it's like, okay, we're going to pause time, go into an ecosystem and weigh everything and then see what the mass is. Okay. And again, almost always it decreases as it goes up, right? So if you have 3,000 kilograms of producers, that could support 200 kilograms of primary consumers, 15 kilograms of secondary, and 1 kilogram of tertiary. Okay. Now, how could a pyramid of biomass be inverted in some ecosystems? Again, this is the exception, not the rule. Well, an example that I could think of is in like a marine ecosystem where you often have a consumer that is massive, like let's say a blue whale, huge, right? And they can eat a lot of really, really small producers. Now, here's the thing. Usually that wouldn't work, right? Usually you would still just need so many of those small producers that their mass would still end up being bigger than the blue whale. But things like phytoplankton that blue whales do eat reproduce so quickly that at any given time, there's actually not that many of them. It's just that soon there will be more, right? So the whale can kind of come by and eat a whole bunch of them, and then it's almost like they just refill again. So there's actually not that much of them, but they are constantly replenishing. It's like you take a drink of a smoothie and it just fills back up again before you can even finish swallowing, right? That's kind of what's happening when it gets inverted like that. So again, you could have a pretty small little producer like phytoplankton, okay, supporting a huge consumer like a blue whale. And again, this usually wouldn't be enough, but the phytoplankton reproduces so quickly that if you pause time and go in and snap a picture, there will never be a huge mass of phytoplankton. It's just that mass will never really drop because as soon as you eat them, they come back. They reproduce that quickly. Because as soon as you lower the population by eating, it kind of bounces right back by their fast reproduction. So at any given time, the mass of the phytoplankton is not that high, whereas the blue whale, just one blue whale is massive, right? So let's say you have, I don't know, 1,000 kilograms of phytoplankton. That might actually be able to support that could actually support a blue whale, which is about 190,000 kilograms, believe it or not. That's about the mass of 190 cars, okay? Blue whales are huge. So that's how a pyramid of biomass might get inverted. But again, these are just the exceptions. Most of them look like this. So to close it out, let's look at the big ideas again. What's a pyramid of energy? A pyramid of numbers? How could a pyramid of numbers be inverted in some ecosystems, not all? What's a pyramid of biomass? How can a pyramid of biomass sometimes be inverted in some ecosystems? Okay. And in all three of the pyramids, what happens to the amount of living stuff as you go up the pyramid? Go for the general ones there, not the weird exceptions. Okay, so that wraps up topic 4 and week 1 of biology. Okay, so if you want practice with this stuff specifically, go try the topic 4 section of the practice work for the week. And if you're feeling good about everything, you've come and asked your questions, you can go ahead and do the summative check-in for the week. Have a great weekend.